Friends, welcome to the tutorial series on network analysis made simple. In this tutorial, we shall discuss on duality principles and duals in electrical networks. Friends, in this tutorial, we shall discuss on what is a dual in general and duality principles in electrical networks. Then we shall define the duality property and we shall also discuss about the duality concept in electrical networks. Further, we shall learn to identify the dual parameters in electrical networks by taking simple electrical circuits. Finally, we shall summarize by listing the various duals in electrical networks. Friends, duality property could be defined as two different things which appear to be similar. For example, two different concepts which appear to behave similar. Two different circuits which appear to perform similar. Friends, the discussion in this tutorial is limited to the property of duality in electrical networks. There are many physical parameters, concepts, ideas, and representations which have property of duality in electrical networks. Friends, to understand the concept of duality in electrical networks, consider simple circuits shown in figure. By writing the loop equation for the circuit shown in figure 1, we get I into R1 plus I into R2 is equal to V. Similarly, by writing the nodal equation for the circuit shown in figure 2, we get V into G1 plus V into G2 is equal to I, where R1 and R2 in circuit 1 are in ohms and G1 and G2 in circuit 2 are in mho. We know that conductance G is equal to 1 upon R mho. Friends, this simple example illustrated will bring out number of duality concepts. We see that by comparing equation 1 and equation 2, we find that the two equations are different. But in what way? Equation 1 is a mesh equation and equation 2 is a nodal equation. Terms in equation 1 are voltage terms, but terms in equation 2 are current terms. Current I in equation 1 is a loop current, whereas voltage in equation 2 is a node voltage. But how should we conclude that both circuits perform similar? Friends, consider equation 1. If we replace I by V, R1 by G1, R2 by G2 and V by I, we get equation 2. Though the terms in equation 1 and equation 2 are different, their performance is same if the corresponding parameters are exchanged. Such parameters are called as duals, and hence we can conclude that voltage is a dual of current and vice versa. Similarly, the loop current I is a dual of node voltage and resistance is a dual of conductance. Other than the voltage, current, resistance and conductance which we identified earlier, many other properties of duality also could be viewed by looking into these two simple circuits. They are: series circuit is a dual of parallel circuit. Loop current is a dual of node voltage. And loop or mesh is a dual of node. Similarly, consider simple AC circuits shown in figure. By writing the loop equation in terms of instantaneous values for circuit 1, we get I into R plus L into di by dt is equal to V. Similarly, by writing the nodal equation for circuit 2, we get V into G plus C into dV by dt is equal to I. Friends, we saw that R is dual of G and I is dual of V. So, in equation 4, if I is replaced by V and V is replaced by I and C is replaced by L, we see that equation 4 will be same as equation 3. Hence, inductance can be called as a dual of capacitance and vice versa. Friends, the duals in electrical networks identified are listed in the table shown. Friends, I hope this presentation has ignited some of your thoughts. Please forward your feedback and suggestions to my email. Thank you for watching.